So we're coming to an end of our unit. Coming to an end of our unit 5, I guess it is, which is Introduction to Integrals. Sorry about all that. Introduction to Integrals. So it's like sort of our first unit on integrals, which means we have to clean up a couple of odds and ends. So there's a couple of things that I'd like to just, we've sort of looked at them a little bit, but haven't used them very much, and I want to show how they're used on the AP exam and in other kinds of questions. And also, it means since we're finishing up sort of a significant part of a unit, means we got to have a quiz. So we're going to have a quiz coming up on integrals. That's probably going to be next week. I'll tell you more about it as I figure it out, because I have no idea yet. But we're going to do some kind of quiz coming up on integrals. All the stuff we've done, evaluating definite integrals, finding areas to solving accumulation problems, solving position, velocity, and acceleration problems, and these things. Okay, so what are these things? So first of all, there's basically 3 different things. Average value, fundamental theorem of calculus part 1, also called FTC1, frequently, at least in the College Board type literature. Understand when you go to university, most people are going to understand what you mean if you say FTC1, but not everybody will. And also there are textbooks that sort of reverse the parts and will sometimes call what we call part 1, they'll call part 2. So it's not entirely universal, but it's kind of pervasive to call it FTC1. But sometimes you'll want to be more specific if you're talking to, in a different context. All right, and then the third one is indefinite integrals, which we did a little bit with indefinite integrals when we were talking about position, velocity, and acceleration last. All right, so the first thing is average value. So average value. The average value of a function. This is also something that has occasionally come up a little bit. We've talked about it, we've bumped into it once in a while. We want to be really specific about it. So the average value of a function, we'll call it VAV, is equal to 1 over b minus a times the integral from a to b of f of x dx. So basically that's saying if I have some function and it's going up and down, it's doing all kinds of things. Let's say this function was the temperature in the room. Okay, the temperature of the room is fluctuating wildly as the heater comes on and off and doesn't always work and somebody opens the window, things like that. And this is time right here. Okay, so there's going to be a certain value that is the average temperature of the room. And that's what this integral calculates. So it's easy to get an average. If you have a bunch of discrete things, you add them up and divide by the number of things there are. But if you have a continuous distribution of things, then to find the average value, well, it's still sort of like adding up the things and dividing by the number of things there are. But since there's an infinite continuity of things, you're adding up the values really means finding an integral, and you're dividing by the number of values you have means dividing by the length of the integral, the length of the interval over which you're finding an average. All right, so let's just look at some of the problems. This is from the book, page 291. I'm going to have you guys do these ones over here where the direction says find the average value of the function on the interval using the antiderivatives to compute the integral. At this point, this was earlier in the book, you don't need this phrase anymore, using antiderivatives, because how else would you compute an integral? All right, of course you're going to use antiderivatives. All right, but this was sort of before they introduced that as a main concept. So all we would have to do for directions is say, find the average value of the function on the interval. That's all it would have to say. All right, now I'm going to actually do, as an example, one from over here where it says use nint, which is, by that they mean use your calculator's numerical integration feature. So, using the integral button on your calculator to find the average value. But I'm not going to do that because we know how to find integrals. This section in the book was from before you knew how to do integrals. And I'm going to do number 13, but I'm going to do it according to the directions that they gave for you. All right, so I'm looking at on chapter 5. Page 291, number 13. So it says y equals negative 3x squared minus 1, and our interval is 0 to 1, and our job is to find the average, sorry about my handwriting, I'm in a weird crampy position here, find the average value of y over the interval. All right, so we want to find the average value. So we see these words, average value, okay? Not average rate, the average value of the function. All right, so we just do 1 over b minus a, this is b, 1 over b minus a, times the integral from a to b of our function, negative 3x squared minus 1, dx. So then I just do, this is 1, so that equals the integral from 0 to 1. I'm sorry, I could evaluate the integral right away. So 1 over 1, that didn't have, it could be like 1/10 or something. In this case, it's 1 over 1. So our antiderivative is going to be negative x cubed minus x, right? We're going from 0 to 1. So that equals negative 1 minus 1 minus 0. And so that's negative 2. That's the average value is negative 2. We can look at what that means graphically, right? You have negative 3x squared minus 1, right? What does negative 3x squared minus 1 look like? We have negative 1 as a vertex. Y equals negative 3x squared minus 1 equals negative, equals negative 3x squared minus 1. So, and this parabola opens down, so it goes like this. And we're averaging over 0 to 1. So it makes sense that our average value is going to be negative. So we're just looking at this part here and saying, what is the average value of that function as we're going down there, where this is 0 to 1. And we can think about what the x-coordinates are. This x-coordinate is negative 1. This x-coordinate is put in the 1, and I get negative 4, right? So this is the point 1, negative 4. And the average value of these two is, the average value is negative 2. So maybe we'll make that orange. So at negative 2 is sort of the average value. My drawing is not to scale. But it does make sense. All right. So that's part 1, average value. That's all there is to that.